Okay, so here's a quick little set of notes for simplified fractions with imaginary numbers. You're going to use inverses to rationalize imaginary fractions, okay? So the idea here is that when we have an example of, like, say, something over an imaginary number, that you're not supposed to leave an imaginary number in the denominator, okay? And so we have to do what's called rationalizing. To do that, what we do is we multiply by the opposite. So I can see in the denominator I have a positive 3i. I need to multiply both the numerator and the denominator by negative 3i. If you pay attention to this, you'll also start seeing some patterns. Okay, I'm going to go through 3 examples and you'll see some easy patterns here. So when I multiply the denominator by positive 3i and negative 3i, I get negative 9i squared. I squared is equal to negative 1, so negative 1 times a negative 9 is positive 9. Negative 3i times 7 gives me negative 21i. Negative 3 times 2 gives me 6i squared, negative 6i squared. Now, I squared again is negative 1, so a negative 1 times a positive 6 gives me positive 6. Now, at this point, notice here how it's written, and I always want the real number by itself and the I number second. So I'm going to rewrite it in the correct order, 6 minus 21i over 9. All of that's divisible by 3, all 3 of those numbers, so I'm going to simplify that by dividing by 3 to get 2 minus 7i over 3. There is no imaginary number now, and it has been rationalized. These two are the same, but this is the proper way that we want to write it. Okay, so kind of notice how they look in the comparison. Let's look at another example. So I've got 15 minus 8i over 4i, negative, and I'm going to multiply by a positive 4i. Negative 4i times 4i is negative 16i squared. I squared is negative 1, so I get a positive 16. Okay, then 4 times 15 is 60i, and 4 times 8, negative 8, would be negative 32i squared, which will become positive 32. And again, I want to switch the order because I want the real number first and the I second. And then when I divide by 16, that's a 16. Notice what you end up with. Now, at this point, this you can tell there's a pattern between these two. Okay? Now, hopefully you figure that out. That technically can be further simplified because I can say I can divide 8 by 4. So I can separate both numbers on top, the numerator, and divide them both by 4. 8 divided by 4 gives me 2. And 2 plus 15 over 4i, because 15 divided by 4 is just still 15 divided by 4. So there's now my final answer. I would take it like this. I mean, I would prefer that if you did it like this and left it like that and didn't finish simplifying, I guess. I would probably still give you at least partial credit. If I mean, not, you know, I might still count it right. Who knows? Okay, so one last one. Oops, showing you the whole thing. Didn't mean to do that. I'm going to let this one play out and see. Okay, so you can see this problem. Now, what do you think the answer is going to be? Okay, based on the other two patterns that you've seen. So here's all the work and here's the answer. So do you see a pattern here? And if you do, that should hopefully start helping you kind of figure some things out. Anyways, that's it for this one. This one's short and sweet. I just wanted you all to see how to simplify these, and there you go. Y'all take care. Thank you.